system can be rather frustrating for some technicians. By reviewing the basic theory of ignition systems and the importance of having the engine properly timed, a lot of these irritating situations can be resolved. There are a number of problems that may appear to be ignition related and are not. Let's take a look at some of these. When the engine backfires through the carburetor, the first culprit to blame is always the ignition system. In order for an engine to backfire through the carburetor, one condition is always present. The engine's intake valve is open. Therefore, a number of checks must be made to pinpoint the exact problem. Number 1. Is the intake valve warped, burned, or carboned up so that it is not seating? 2. Is the camshaft properly timed to the crankshaft gear? The scribe mark and hobbing hole must be in line with the chamfered tooth or dimple on the crank gear. The only exception to this rule was the old Craftsman engine with the ramjet carburetor. Another important thing to remember with the valve timing is that sometimes the sudden stop to an engine does more damage than just shearing the flywheel key. Camshaft teeth have been known to break, as well as the crankshaft gear. With the pressed-on crank gear, it sometimes spins on the crank. The correct location for this dimple or chamfered tooth is approximately the 2 o'clock location when the journal is at 12 o'clock. An easy way to check this without tearing the engine sump apart is to watch the valve action as the piston moves up in the bore on the compression stroke. This will allow you to see if the fuel is getting in too soon or too late. Third, as mentioned earlier, is the flywheel key sheared from a sudden stop? Has the proper flywheel key been used, and has it been positioned properly? And finally, has the engine been timed properly? If the timing is advanced, the engine will fire while the intake valve is still open, causing backfiring through the carb. There are several ways to check for spark. Let's look at the safe ways. The safest way to check for spark is to hook up a spark tester to the lead wire and to the plug. A hot, bright blue spark should jump the gap. If the spark is orange or yellow, the engine will not fire under compression. Checking some solid-state modules without having the secondary of the unit grounded can cause failure to the unit. If the engine has been taken apart, there are a number of suitable testers to check the components. The use of some of these testers will be shown later. It is not a good idea to check for spark with the lead wire disconnected from the spark plug. The possibility of shock is great. An extremely dangerous method that should never be used is to remove the spark plug and check for spark. Gas will be sent out the spark plug hole, and any type of spark or flame could ignite, causing a fire. Never use this procedure. If a spark is not present, make the following checks. Has the control been moved to the start or run position? Is the engine ground wire damaged? Has a bare spot been rubbed in it, causing the electrical current to ground out? When it's possible, isolate the engine from the equipment. With the numerous safety switches in use, it's possible that they may be at fault. If this is the cause, all new ignition components and your time won't help. A faulty key switch can also lead to a grounded ignition system. In some cases, with a bad switch, battery voltage will be fed back up the ignition ground wire and destroy the electrical components. Double-check the wire on the equipment and the polarity of the battery. Reversing the polarity will also destroy the ignition components. Another instance of no spark may be in fact that the magnets have lost their power. It is very rare that the magnets lose their magnetism, but it can happen. The only practical way to check the magnets in a repair shop is to place the flywheel on a wooden surface. Grip a long screwdriver by the handle. Move the blade of the screwdriver to within 3/4 of an inch of the magnets. If the blade snaps to the magnets, they still have sufficient strength. In checking the flywheel, make sure that it is not damaged. While looking at the flywheel, if there is a crack to the right of the keyway, that indicates a severe sudden stop. If the crack is to the left, it is a sign of improper torque to the flywheel nut. Never reuse a damaged flywheel. The statement has been made that the engine is backfiring at the muffler. Flames are shooting out. This condition is generally not an ignition problem unless the timing is so retarded that all of the fuel in the combustion chamber is not being burned. The excess fuel is sent into the muffler on the exhaust stroke of the engine and is ignited by the heat of the muffler. This condition is generally the result of too rich a carburetor setting or a leaking exhaust valve. Timing a Tecumseh engine properly is critical. An engine that is out of time just will not perform satisfactorily for anyone. An engine that has the time too far advanced will kick back, possibly causing injury to the operator. An engine with retarded spark starts easily but lacks power when it needs it. When the engine is timed properly, it will start easily and respond to the power demands of the equipment. We have mentioned a number of conditions to look for when troubleshooting ignition systems. Well, how do you check the actual ignition components?
Good evening. Thank you for joining me this evening for a very enlightening, informative, and very interesting game of ignition checkers.
We're going to take some time and talk about electrical testers and not ignition checkers. And we want to talk about some of the things that you should consider when buying an ignition tester. We're not going to tell you today that this tester is better than any other tester, but what we are going to talk about and give you some guidelines that you may use to select a tester. There are a couple questions that you need to answer in your mind about ignition equipment before you purchase it. What can your shop afford? Test equipment is not cheap, but by the same token, don't buy cheap test equipment because it will not give you the results that you want to know. Another important question is, what do you want the equipment to do for you? Do you need to know what the series resistance is in the coil? Do you want to know how many microfarad your condenser holds? If so, then perchance you'll want a piece of test equipment similar to the one here that has the needle indicator and will give you those readings and the scales to read them. If that's the type of test equipment that you prefer, then this may be the style that you want to purchase. If your concern is the equipment or the component good or bad, and that's all you want to know, then you can buy a couple other versions of the testers that are either a go, no-go version, and there are several styles available on the market. Another thing that's important when looking at test equipment is to in fact find out what will the test equipment test. Not all the test equipment will check solid state ignition as an example. So there's no sense in making that investment with today's day and age of solid state ignition if your component tester will not check solid state ignition. So make sure that your equipment will do what you want it to do. Now, in a couple of the major lines of test equipment, Tecumseh has produced and provided the test manuals for both the Mercatronic and the Graham Lee product line. As you can see on the screen, the part number for those books is available. Another important book that Tecumseh has produced, and that's the Ignition Troubleshooting Booklet, which again may help you through some of the tough ignition questions that you may have. Let's take a couple moments and show you how one tester works real quickly, which is the go, no-go type tester. The unit that I'm going to demonstrate today is the Graham Lee 31 SMXH. The tester is relatively easy to use. You connect the probes as the color key shows on the tester. You can turn the tester on, and by looking at the amber light on the tester, you can see that you have continuity. Let's make a relatively quick and easy check on a coil. The short wire with the eyelet on the coil is the ground. So we hook the black lead to the ground. We can hook to the primary of the coil and see that we have the amber light glowing again. That tells us that we have continuity through the primary of the coil. If you disconnect the red lead and touch it to the spark plug end of the coil, you can see that we have continuity through the secondary of the coil. The continuity check mainly tells you that you do not have a break in the windings of the coil. The true test for the coil is in fact a power test. So we have the black lead hooked to ground, the red lead hooked to the primary. Then we take a jumper and hook from the secondary to the air gap of the tester. Now, in reading the manual, number one, you will need to know the part number of your condenser, or excuse me, of your coil, and the test procedure. On this tester, we're going to want to turn the knob to the left, which is a spring-loaded knob, to the on position, and then rotate the indicator until the coil fires. We can take the reading and see that this coil is firing at about 51 on the scale. The coil must fire before it reaches 60. Now that's a quick and easy check for checking out a coil. The test booklets are written well so that the checks are easy to make and easy to understand. And it only takes you a few seconds to hook them up and make the checks to see if it's the ignition component itself that's causing your problem with the ignition system. In the program today, as we've looked at it, we've talked about basic theory of ignition systems, to timing the engine, to troubleshooting, and now to ignition test equipment. We hope that this program has given you different aids and directions to help you in the troubleshooting and the repair of Tecumseh ignition systems.